And the next presentation is by Dr. Sunil Ganju, who will give us the funding agency perspective to some extent.
Yeah. So is it visible right now? No. Just give me a moment.
It is visible. It is visible.
The presentation is visible?
Yeah, it is visible. Thank you.
Okay. Yeah, fine. Yeah. Okay. So thank you very much, Dr. Godbole and Dr. Swapan Chattopadhyay. Of course, my participation in this event is in a true sense a non-physics participation. I am not at all related to any of the physics which has been discussed over the last couple of days. And as the title itself suggests, this will be more of, I can say it will be more of English rather than physics. And I will also like to mention one thing here. When I talk about the Government of India perspectives, it essentially is a perspective, it is my perspective for the perspectives of the Government of India, because on behalf of the Government of India, DAE and other scientific institutions like the DST have been the nodal agencies or the coordinating agencies for funding of the various mega science projects which have been in place for quite some time now in our country. And the background of my presentation here is that somewhere in 2019, late 2019 and till the end of 2020, we were involved from the department in a review of all the mega science projects, which was sort of directed by the chairman of the Atomic Energy Commission and Secretary DAE. And this committee, which comprised of the then PSA, Professor Vijay Raghavan, Dr. Saraswat, Dr. Grover, besides me. And I'm glad that now when Professor Amol Dige has talked about the vision document, many of the elements which were basically part of our deliberations that time seem to be getting reflected into a proper document, which perhaps will see the light of the day at some point of time sooner. So with this background, my presentation is a very short presentation, and I hope it is a sweet presentation. And I'm glad that Professor Dige has maybe elaborated quite a bit on few of the points which I had just touched upon in my presentation. So the first and foremost thing which I would like to highlight here when we talk of our mega science projects is a cycle which goes into the thinking of the government or the funding agencies. The science has to lead to some technology. The technology has to be either used by the industry, or the industry has to come up to the technology levels to be able to deliver the specific equipments or components. And all these things, while we are doing all this, it has to ultimately be of some use to the society, which again will give a feedback to the science community so that science keeps continuing. So it's my perception that this is a loop which keeps on evolving over time. The loop may be spread over a few years or decades. There will be long-term goals. There will be some tangible assets or tangible deliverables. There will be quite a bit of intangible deliverables also. And the central part of all this is the human resource component, which is involved in each of these individual elements here. Coming to the tangible and the intangible part of this whole cycle, when we talk of science, we always have a lot of intangible things also, because it helps us to give. It's intangible in the sense it's not that it doesn't yield good results, but then somehow, somewhere in the community, in the larger community, it does not perhaps get recognized the way it should have been. And then when it becomes tangible when the industry gets involved, when your technology gets involved, and ultimately, as I said in the previous slide, it goes into the society, giving up some benefit. It's a small example which I like to really quote here. There has been a lot of discussion in the recent past where this issue of the manual scavengers was, in fact, it still is, was a big concern for our country. So how our science and how our technology can help overcome this problem ultimately is what gets reflected in the advancement of our society. So that is how we try to correlate the science and technology. And coming to the specifics of the societal applications, it has already been pointed out in our earlier presentations during the start of this meeting. Many verticals or collaterals, I can also say, are getting derived when we talk of the physics/particle accelerators, the health, industry, biology, material science, fusion, and all of these have been touched upon in the previous presentations and more emphatically in the presentation which Professor Amul just now made. Coming to the mega science projects, I'll be concentrating right on the mega science because that is what we have been handling so far. And I will like to refer here to one of the beautiful pictures which was conceptualized a few years back when a Vigyan Samagam was held by DST and the National Center for Science Museums. This was conceptualized by my predecessor, Mr. Arun Srivastav. And this summarizes the whole gamut of the horizon, which perhaps has been deliberated upon in the last few days, and which will continue to be the driving force for the physics community, the high energy physics community, the nuclear physics community, and also the other allied branches. And when we come to the Indian mega science projects, all of us are aware of the various important contributions and participation of our institutes, whether they are from the DAE or they are from the DST, the academic institutes or autonomous institutes. They have been involved in many such activities in a collaborative manner. A lot of funding has been earmarked for all these projects. Giving a summary of these budgetary numbers, of course, maybe for our international participants, I am quoting all these numbers in rupees crores, but roughly the overall outlay for all these mega science projects is $2,500 million, which spreads over 10 years, in some cases even 15 years. And many of these are ongoing. We have a collaborative framework for many of the projects with either the DAE or the DST being the lead agency, while the other counterpart becomes more of a funding agency and a coordinating agency because many of its institutes are participating. So when we talk of the evolution of the management structure for this, the overall budgeting, which involves these projects, involves the cash or in-kind contributions. We pay some sort of subscription fees or annual membership fees for participating in various collaborations. Then we have capabilities to deliver some components for the various facilities which are coming up, which we call the in-kind contributions. As I mentioned earlier, we have a concept of the lead agency, where the lead agency becomes the front runner for the international collaborators, while the others become the supporting members. The mechanism for this management of this mega science projects, that we have a joint technical evaluation and approval mechanism. We have task forces for various projects. We have got councils. We have got management boards, science management boards, for example, in some cases, program management boards in some cases. We have an overall, because right now what I'm talking about is the DAE DST mega science projects, because most of the mega science projects, rather all of them, are being steered by the DAE and DST together. So we have an Apex DAE DST coordination committee, and there is also a joint implementation oversight. The capital costs for the various projects, they get borne equally shared by DAE and DST. And when we talk of the recurring costs, in case of DAE being the lead agency, DAE bears the recurring costs. And for DST, when they are the lead agency, they bear the recurring costs. So that is roughly the model. I like to briefly touch upon what we have traveled so far, what we have gained so far. It definitely has been, when we started participating in the mega science projects, we were, I think, in a much infant stage. Nothing much was happening on a larger scale. Yes, we have had a large physics community, we have had large researchers who were really doing this high-end research in their respective labs or their institutes. But the mega science projects offered an opportunity to become part of a global conglomerate, if I can say so. And this way, we could get a great experience when we were part of the technology development and right from its inception, and we could collectively contribute to the science goals within the world community and make ourselves, come at par with the other world community. That has been one major takeaway. We have really matured in sense of pursuing science, in adopting technologies, and perhaps even implementing the various contributions and supplying various important components, hardware, software, and even human resources for the various mega science projects. There has been a large, very positive feedback from all the international collaborations, which has been in terms of either the human resource training, the engagement in development of advanced technologies, industry partnerships, which has been a valuable input for our indigenous programs. And I think I will also like to highlight here the objective, the primary objective of our participation in this mega science projects has always been to strengthen the domestic programs and come into a possible standalone mode or as a driver for all these programs. Instead of followers, we are perhaps now capable of driving many of the mega science projects, and perhaps one has to take a paradigm shift in trying to engage and trying to evolve such type of projects where we become the hosts and the world community participates as our collaborators, the way we have been doing it till now. So that brings me to what we can expect further ahead. We have to definitely lay emphasis on the benefits which were beyond the conceptualized objectives for the mega science projects. We need to develop a very good project capability where we can understand not only the scientific background, but also enhance the design and R&D capabilities within our country. And definitely when I talk of this, when we started collaborating with our international partners, the understanding from that side also was the same way that all the international collaborators, all the host countries for the various mega science projects will be helping this country upgrade our capabilities, whether it is in terms of science, whether it is in terms of technology, whether it is in terms of industry, or even human resource. Human resource becomes a very, very important element in all this, what we say, in all this whole roadmap. And however, we need to really plan and prepare a cutting-edge roadmap so that India could come up as a driver. I have already mentioned this, and we can collaborate as a host for all such related R&D in our future. Already Professor Dige has touched upon such type of elements in the report which have gone there, and I'm really glad that these type of things have already been thought of. The research community, when I talk of the science community, we need to, as a researcher myself also, I have a scientific background, technical background, there have to be gap identification and how do we build them. We have identified over the course of our association, there have been gaps, and how efficiently and how quickly we can fill these gaps. So we should be able to derive benefits from these international collaborative projects, which really help us in building up our domestic programs. We have to be maturing from just being followers to being front runners and focus on the deriving the advantages by learning the design and development and also pursuing project development so that we can handle and manage such projects in a standalone manner. Coming to a few other steps, which already in fact have been mentioned, and I think it must have been, I unfortunately could not participate in all the technical talks. And I'm sure this has been definitely discussed and highlighted in the discussions during the meeting. We need to learn, or we need to take steps to leverage the spin-off technologies. We have a lot of spin-off technologies. Part have been implemented here, whether it is for wastewater treatment, whether it is for water purification or something like that. And coming back to how we try to involve the young minds, we need to really work on a proactive outreach program, which can bring awareness about the benefits of these participations in our projects. And in this context, I'll just briefly mention that recently DIE has started a Parmanu Jyoti program, which aims at reaching out to schools spread across the length and breadth of the country. Our people, our scientists, our technologists, our engineers go to these schools, participate in the day-to-day activities of the school. They don't go there as teachers. They go there as participants. They interact with the students and try to inculcate that inquisitiveness about science, because I think that is what will really rekindle the attitude towards science. And perhaps that is how we can again come back or bring back science into our graduate studies, where there have been challenges, as already has been mentioned, which also can perhaps help in a way to stem the type of brain drain we have been experiencing. We have been talking of brain drain for a long time, but still we do know that it is a challenge which we will need to address. And this could be one way where we can strengthen ourselves and try to upgrade from within. So the next element which will definitely need to be very, very emphatically looked upon is the societal applications, which makes the returns from these mega science projects very tangible from the policymakers' point of view, from the government's point of view. So I think I'll stop at this. I have just tried to take advantage of what already Professor Dige mentioned, and I'm glad that it has already been covered. So I have just touched upon a few points, and I hope if there are more questions or queries, I'll be able to answer it further on. Thank you very much.
So thank you very much, Dr. Ganju, for making this very succinct and very clear presentation. What I would like to suggest actually is that you please remain online for the panel discussion.
Yes, yes.
And what I want to suggest is that we will begin with the panel discussion. And in the process of panel discussion, if people want to ask you specifically any questions,
sure,
we will take them up at that time.
Sure.
So please remain online.
Yeah,
And
I will
also,
be here. I'll be here.
Yeah, thank you very much.